And now we can continue with the second speech. Please welcome Bobur.
Yes, thank you. I see some people are still finishing. So shall we start? Okay, right. Yeah, first, thanks to Miguel and the sponsors, DEVCLUB, for inviting me. I'm a guest speaker, so I can't take a longer time, longer than 1 hour. Where is my microphone, by the way? Microphone. Or is it sounds is good? I can use without microphone. I can speak now.
Better to use a mic.
1. 1, 2, 3, 4. Whoa. Good, good. Now with the microphone is much better. My topic is more technical, not like a non-technical as we have seen already in the first speech. Like it's more about people management. My talk is like a pipeline management. How you can manage your pipeline efficiently nowadays using modern technologies and tools, correct? First of all, let me ask you, because I saw already a lot of Java developers here. Is there any Python developers participating? Oh, I see 1, 2, 3. Oh, good, good, good. Maybe I can change my question. How many prompt engineers and software engineers here? Because we have a lot of prompt engineer, software engineer. Ah, okay. Because nowadays it's easier with AI to write code in any language. I mean, I can write, if you want, in C++. I'm a Java developer originally, I'm not a Python. Today's topic is not truly about Python, but about how you can manage your pipeline efficiently to optimize your team performance, and then how you save some money for your team, right? And next question gonna be, how many people use Kafka here? Oh, in this case, for you, it would be quite interesting, very, very relevant. I like Kafka. Let's start. For example, all these real-time processing tools nowadays, including Kafka, Java-based, correct? And nowadays, but we have seen that Python are gaining, Python programs gaining a lot of popularity among Python developers, data engineers, even among Java developers. Because of why? AI hype. Because everybody wants to learn AI, wants to integrate AI, and all this Python has a rich set of tools and libraries like pandas for data manipulation and analysis. That's why Python is gaining more popularity than Java nowadays. Because of this reason, to bridge this gap between Java and Python, we are seeing a lot of libraries, technologies and tools are developing to support Python for Kafka. Today's topic is all about this. You can choose Kafka as a Python wrapper library, or you can use full Python to build your real-time pipelines or any kind of pipelines. Let me introduce myself. There's a lot of talk. My name is Bobur. Once again, I always tell, if you cannot pronounce my name, you can call me Bob, which is shorter version, or you can call me Tiger. Bobur means tiger in English. And my Umurzokov, the family name, it's live more, tiger who lives longer in this life. It's how I explain. I'm a developer advocate. By the way, I run a small developer relation consultancy here in Estonia. But unfortunately, we don't have any developer tools developing in Estonia. That's why I work for foreign companies, mostly for US companies, because in US, 80% of the developer tools are built not in Europe. So, and if I say more marketing pitch I can do, I'm a business owner, a director, or general director of my company, my own company, right? And I'm doing some stuff for Microsoft as well as Microsoft's MVP for Azure AI services. I like the AI tools. I will explain more in the next slides. Let's start with my story about the Bob. It's not me, but it's another Bob. Our story begins with Bob, who is a data engineer who works at one mid-sized company called Dream Together. Bob Dreamer works at Dream Together. They are building an innovative car selling online platform where you can register your car for selling or buying, which is easy, right? We have also some websites where you can buy and sell your cars. And he's a data engineer. He would like to introduce new solution for their website where when someone can register a new car with attributes like a BMW, it's a new car with this engine, and he wants to build a pipeline to find the price recommendation for the car, depending on the attributes. Let's say if it's new, price is higher. But this price recommendation system works with AI. AI analyzes the input of the car, pictures, some stuff, and analyze what is the price for this car, its ideal price. Clear, right? This is a requirement. What he wants, because of recent AI hypes, everybody's talking about around him. AI is good. Let's try it. And once he explains to his team about his solution, everybody likes the idea. Bob, you have 2 weeks to build a proof of concept. Let's do that. And he starts to understand first, as he has a data engineer background, first reads some books and asks GPT to understand what is the difference between batch processing and real-time data or stream processing. How many of you know batch processing, stream processing difference? You know, okay, okay. So many of you. I can explain a little short. It's very easy. Batch processing works based on a schedule. You say, okay, let's say take the data from one point, push the data to the destination based on the time. Let's say at 5 p.m., pull this data and push to another destination. This is a batch orchestration. And there is stream processing. Whenever something happens on the data source, it should go instantly to the data destination. It's a real-time data processing, correct? He understands, okay, in this case, he needs not a batch processing, correct? Because the user should see as soon as possible new car registered or updated the car information. The price should reflect on the real-time information. So he chooses the right side. So, and next, and he understands like, okay, real-time data processing pipeline, how it looks like. When we say data pipeline, as I said, like moving data from data source to data destination, but when you create a real-time keyword, it will become whenever something changes in your relational database or any primary database, maybe in your CSV file, it should detect these changes and immediately send to the destination in the middle by transforming this data. Transforming means like you can enrich your data, you can add some additional fields to your JSON, or you can filter, you can run some machine learning models to update this input data before sending to destination. Everything happens in milliseconds. Maximum 1 second, it happens, and then the transformation is done. And the data sync can be your BI analytics tools, any real-time application like microservices, where users or the engineers can see the output of the transformed data. Now everything is clear, right, about real-time data processing. For Bob, also clear. He understood this, and then starts next. He comes up with first proof of concept for his solution for a real-time price recommendation system. As you can see, it's quite easy. They're using PostgreSQL as a data source, where all the system, car prices, users, all of the data is stored in PostgreSQL. And he adds additional service called Debezium. Debezium is an open source service that can capture data changes. Every insert, edit, or delete can be captured by this service. And when you capture this data from your primary database, he wants to use Kafka to stream this data to their prediction service. Its prediction service, you can see on the right side, is just a Python script that communicates with OpenAI to send some car price data and calculate AI analyzes car data and says, okay, this is my price. This is the price for the car. So approximately, instead of using OpenAI, of course, you can use your own machine learning. If there is any data engineers, if you try to build ML, no, nobody? Machine learning? Okay, okay.
So we use one service.
Service, okay. There are some services, of course, on Google, AWS, and Microsoft provides, right, some machine learning models you can try. But if you cannot, if you don't want to try, you can use OpenAI to generate something. Clear, right? Architecture. It's very easy, straightforward. And here, after he faces some challenges, even with this small architecture, okay, he was able to create a proof of concept, but now he wants to implement everything in Pro. in production and make it available for customers. And he faces these challenges. First of all, even creating proof of concept, because he's a data engineer and he doesn't have experience with Kafka. Unfortunately, maybe he has a little bit of experience, but he doesn't want to also spend to learn Kafka or deal with infrastructure, like DevOps stuff. Because every service, as you saw in the previous slide, is an independent service, right? It's a Debezium independent, Kafka stream is independent, and production service, two services, like we have multiple services. You need to orchestrate them somehow. You need a DevOps guy. And he wants to also use everything Python because Python has, of course, very good libraries for ML and AI things. Even if you see any LLM providers, they are always supporting first language as Python, like from Google or OpenAI. And most importantly, he faces that Kafka is not enough to stream data from the source to destination. He needs to use Flink or Spark to support the streams. Why you need Flink and Spark, I'm going to explain soon. Why you cannot use it along the Kafka. You need additional libraries, additional tools, because the Flink and Spark can do some stateful transformation. If you would like to aggregate multiple cloud prices, you need to work on multiple input data, correct? You need to store somewhere. Kafka doesn't store anything, but Flink and Spark can store and analyze your data. If you build some pipelines already, you know, like you need some combination. So he wants to avoid this combination. He would like to be fast in the modern 2024. So, and next he starts to analyze again how he can improve first his proof of concept by asking GPT. Obviously, GPT cannot help him, and he asks his real friends. And here the real friend says about Kafka. One of his friends says, yes, for us, Kafka was good at the beginning, but it took 9 months to implement Kafka-based real-time data pipeline. That's why we decided not to use Kafka, because there are other tools nowadays, Kafka becoming old, and so on. Another friend says, yeah, we have very enterprise company level, we have 50 teams. They are relying only on a single cluster, one instance of the Kafka, because they don't know how to manage. That's why they just monolith one cluster enough for 50 teams, but they are having performance issues. And now they would like to replace again. The third one problem is you need the Java engineer always. If you don't have a Java engineer, you cannot deal with Kafka because all libraries, tools, technology supports Java. They don't want to hire specifically to manage a Kafka Java engineer. That was the problems. Yeah, I know we have a lot of Java developers here. I removed actually logos of the companies because of the presentation, but actually this problem is coming from some well-known companies. One of them is Amazon. I'm not going to say which one is Amazon, but there was a problems actually real. And these problems comes with why? Because there are two ways to use Kafka. You use your own, you build everything from scratch, like we call it self-managing Kafka. Or there are other way you use some Kafka managed providers in the cloud. Let's have a look first one. What are the challenges with Kafka when you want to self-manage it? We see the problems like, first of all, they don't know which team is responsible to manage this Kafka. Is it DevOps teams, or data engineer, or Java engineer? Or maybe tech lead is going to deal with Kafka headache. They don't know. And then also, they need to train now some new developers how to use Kafka. It's also costly for some companies, if it's a startup company or medium level, not like big enterprises. And some other problems here, how you can upgrade brokers, how you monitor your Kafkas, how you scale it, performance it. Even before implementing something, you have already so much problems, as you can see. And there are other challenges. That's why you decide to not use self-managed Kafka. Bob, because Bob decided not to use self-managed Kafka. He wants to use ready solutions, like Amazon provides ready solution, Azure, Red Panda, Upstage, Confluent provides. Again, yeah, it removes some infrastructure overhead from you. You're using managed Kafka, but you pay for it, of course. But it comes with other challenges again. You need still Java engineer. I'm not saying like we don't need Java engineers at all, but Java engineers has another responsibility. They need to develop backend application, not manage every time the Kafka or stuff, right? It's a lacking of the skills in the middle, like DevOps skills and Java skills. If you separate it, Java engineers cannot become DevOps engineer, or DevOps engineers cannot become Java engineer. So then security perspectives, it's one of the biggest problem. Small companies, they don't believe to deploy their Kafka data pipeline solution to the third-party provider because of security. They don't want to expose internal data to data providers. That's why Confluent recently also acquired for some millions new startup called Wobstream. You can have a look. It's quite interesting story. Like two young guys, they started in 9 months this new startup and they sell. And then Confluent paid for them. Now Confluent wants to give their customers, users, they can deploy on your cloud securely and with less cost. This is called combination. I just draw this square. So let's have a look. Okay, Bobur, like you're a developer advocate, you know the experience how developers face with this Kafka. Here, let's say in Bob's case, even he's using managed Kafka, he needs to choose one of them. Let's say he chooses Confluent. And the next steps comes, he needs to install or write a code in Java to stream events from Postgre to the provider, managed service provider. So you need to write some code for that. And then you need also some additional virtual machine to deploy Spark of Link. For what? For computation. Because Kafka just streams data, but the Spark of Link does some processing. Reads the data and blah, blah. And other issues like you need to manage, optimize, scale infrastructure. All this setup happens before you write a single line of code for your data pipeline. In Bob's case, until he implements a prototype service in Python, he needs to build this infrastructure whole. This is the challenges we see nowadays. So let's come back to the topic, why I'm always saying Kafka together with Flink always useful. As we understood, Kafka just a streaming data solution. Just takes the data and pushes away, and data goes to some other destination. But here, Flink can process and analyze your data by transforming it, aggregating, storing somewhere, right? And then it will send to the other destination. But here, why I'm showing this picture, as you can see in this process, so many teams are included. Like AI, ML engineer thinks about what kind of AI solution they can use, like ML, maybe they will build something new. And then they need to obviously DevOps, because someone needs to know Docker, Kubernetes, deploy their services. And other people, data engineer who builds this proof of concept like a Bob, he needs to know which library to use, which data source to connect, and software engineer, of course. In this part comes software engineer to connect the data pipeline and show on the website car prices. You see, so many teams are involved. But however, another issue, not about the multiple teams involved with Kafka or the Java-based real-time data processing solutions. Here, as you can see, if you want to run Kafka for Python, you always write in Python code, but in the hood, it translates to Java code. That's the main problem, like performance issue comes from here. You need to implement one transformation function that converts, let's say, pandas library to the virtual machine library. It takes a lot of time. I will say, like, even every second is important in this process. That's why people now start to think why we should use Kafka, because there are a lot of infrastructure, cost, performance issue. And then next few slides, I'm going to explain what are the solutions we have. Because data teams, they want to be self-sufficient in Python without thinking about infrastructure, without thinking about the cost or hiring someone. And we see also from some well-known companies, like some issues having, and this picture actually highlights a little bit old, but I have checked it today, even Python become like even third most popular language on Stack Overflow, other systems. You can have a look. And he writes a blog post about all the issues. I will gonna leave this QR code here if you want to read more in depth, like what are the pain points Blob faced. Some of the pain points I like explained, but it took hours for me to go dive into show you what exactly the pain points. You can read here. So Bob starts now. Okay, I'm gonna fed up with Kafka. I would like to choose other alternatives. Other alternatives here, as you can see, you can use some solutions from Microsoft. Like we have Microsoft Azure Event Hubs. It works with Kafka and without Kafka. It triggers on every event, and then it provides for your infrastructure. Or you can use from Amazon. There are very popular library coming up now. It's called NATS, open source. Also message broker. You can use instead of Kafka also NATS. And then the solution we are building nowadays is called GlassFlow. I'm going to show also shortly how does it work. It is a Python library. Let me explain a little bit about this. Why Python for streaming, not Java or Kafka? That's we're going to cover next slides. Let's see. First of all, you see from the previous slide, like we have two different components we need to create a pipeline. Kafka Flink. If you're using Python frameworks created recently as an emerging technology, you don't have to use both Kafka and Flink. All the streaming data part and also processing part will be part of this your library. When you install it, everything will be installed automatically. Your task is only to connect by writing some code to data source and by connecting to the output. And everything will be handled automatically inside this diagram. As you can see, Python-based framework, one of the benefits in terms of infrastructure. Let me show you other benefits here. There are libraries, of course, for Kafka and Java, and the frameworks on the left side, libraries on the right side. Libraries like PyFlink, Kafka for Python, just a wrapper library. They provide API on the top of Kafka library. Java libraries. That's why we saw they have some issues. And then on the left side, you can check these new products coming up. I think last time I also demonstrated Pathway, French company. They became also very famous in the recent days. I'm not working for them, but now I'm working for another company. But you can have a look. Like it's a new technology. That is my task to provide the knowledge how this stuff works. And another thing I really like in this Python frameworks, as I said, you don't need GVM. Maybe if you want, you can still use Java. There are some supporting Java also libraries in the Python framework. You can still write in Java, but infrastructure, everything is in Python. And another thing is you can use with any library, if you're using Python without this conversion and a complex initial setup, I have already covered. And they do automatically this incremental in-memory transformation, which means like over time, the car price changes for the one car, only one single car. You can see, okay, show me top 10 price for BMW car for the last month. You can see all this incremental analysis of the data easily in single line of Python code. And some of them also you can run from Jupyter Notebook. How many of you use the Jupyter Notebook here? Yeah, okay, yeah. So it's easy, right? You can write any code and you can run in a single page. And the same with Python frameworks, like instead of installing anything, you can just write the code and everything installed on Jupyter. That's one of the benefits I really like here. So, and about specifically GlassFlow, what we did also, we tried to combine both this Kafka and Flink into one platform. I'm not going to do this here, more marketing pitch. I'm going to show a couple of examples what you can do with GlassFlow. Here, as you can see, the architecture, how it looks like. We have some integrations. You can integrate to any data source, like existing maybe message brokers, like Amazon SQS or Azure Event Hubs, Amazon Kinesis, PostgreSQL or MySQL. It automatically detects a change happening, or we can specify what kind of change you would like to send to the transformation. And transformation runs in the serverless environment, like in the cloud. You don't have to manage if there's a high load, you would like to transform billions of car price data. It handles scales automatically. This is a magic part of the serverless transformation. And then of course you can use everything in Python. In other words, how I describe, not the GlassFlow in Python string framework, here how you solve shards like in our Olympics. If you solve it like very casual and simple, like zero infrastructure, you can do everything. That's how I compare now, like Python frameworks nowadays. Let me skip this part. And then, yeah, under the hood, like I would like to show, not only GlassFlow, this Python framework uses these technologies like without Kafka, Docker, NATS, Kubernetes, because Docker, Kubernetes, more infrastructure, NATS for message broking. That's why I'm saying like it's already using built technologies. You are writing implementing application low code, right? Low code means you write less code, but you have an application at the same level. You write everything from scratch. This is something like we would like to achieve also for creating data pipelines. So, and next question asks Bob, like, okay, Bobur, you are talking a lot about Kafka disadvantages, and then show me some examples, real world examples, what I can do, what kind of pipeline I can build. One of the example is, still it's learning, but it's with real-time clickstream analytics. One of the example, like where you can analyze your website performance. In real time, someone clicks, someone visits your website, and you can build some dashboard based on the website analytics. We call it the real-time clickstream analytics. Another pipeline example is how about combining with AI, real-time classified ads enrichment, which means if you open the Amazon.com, you can see some ads showed based on your preference, right? Or you can open any e-commerce platform. Based on your location, based on the pictures or the products you have seen recently, it will change updates in real time. This we call the classified ads, show the customers that they would like to see something in real time. This also you can achieve with easy steps. There are some examples I have already provided. You can try out, it's for free. Another example, this one I really like it. I built this use case myself, like how you can continuously update your vector database. It's technical naming, but let me explain you. We are connected to Airbnb data set. Airbnb, where you can, how many of you know Airbnb? Everyone knows and use it. There are some property listings, right? Your apartment you can find some cozy apartment in Paris. What I did, like I connected this data and I ingested this data to somewhere else, like in database. You can use Crossbase or Superbase. I will explain why Superbase at the end, like it's quite a good tool. Superbase, it's nowadays also open source. They are trying to replace Firebase. From Google, because it's open source. Firebase is more paid, and then what I did, whenever new listing is added to Airbnb, I would like to calculate first of all write a description for the Airbnb, then also analyze if this description is similar to the user, what is user searching for. For example, I always write on the Google search, like I am looking for, specific keywords I give, right? Apartment in Paris. But now I would like to ask as a human, show me in Paris a cozy apartment next to the sea. Or there's no actually sea, but next to the river. And in this case, human language, this solution can understand human language. When you're asking, it will convert your language to the query. It's a similar like SQL query or any vector database query. Have you ever built an AI application here, everyone? No? Yeah, some of you. Have you used maybe vector database? Because the vector database analysis is gaining popularity because in building applications, you can store vector representation of your data. which means it's easy to query this data. So whenever human language comes, vector database can convert your human language to the vector representation and give you output. This sort of solutions you can build also with these pipelines. Another solutions like a use case I was building is real-time anomaly detection. Anomaly detection means like in security, for example, your data can be corrupted or your data can be missing some information, or in the logs you can analyze depending on who is entering into your system. You can alert other systems, okay, this guy is suspicious guys entering into the system, and from the logs AI can analyze this if it's positive or negative impact of the AI. Okay, I'm going to skip this real case. You can explore also these use cases. I'm going to put here square code and share the slides as well. Just all your 4 use cases. There you can find more information. Today I'm going to explain another solution of the Bob. Let's come back to the Bob. Bob was first solution with Kafka and without Kafka here solution. The same real-time project recommendation. This technology I'm using the one Python framework. And data transformation, it's just Python script. I will show you how you can achieve the same result using Kafka with other tools. Like a Superbase, because Postgre works best with the Superbase as well. You don't have to migrate your data. Superbase is just a higher level. You can still query your PostgreSQL, but it makes real-time data available for the output services. And then we can use some webhook to trigger some data transformation in the middle to convert your input data and calculate the price. Let me show you the demo part here. How you build my application just in 15 minutes. That's why I said minutes. I created my Superbase database and migrated car prices. As you can see, I created one car price table with all the necessary data, like a car model price, fuel type, energy size, and so on. And I put some data into it, it's just dummy data, to test it out, like how the car price changes. The next step, I'm going to also, now you will see the build data pipeline using the GlassFlow, the tool, Python framework, without writing any code. You see, I'm just using the low code, creating my pipeline for the Bob's case. I'm providing pipeline name and then specifying the input source, webhook, because webhook is nice when you are building some polling mechanism, like you can just trigger some events when something happens. In the transformation layer, as you can see, I write some simple Python code, just does what does, so connects to OpenAI, and then I'm just giving some prompt. You are like a great data analyst, please analyze this kind of price and show me a suggested price for the customer. Then I'm putting in the transformation just in the builder part. So you can use even like OpenAI API key or any other providers for LLM. Then output data, it's the destination of your website. Your destination website, just I'm illustrating here. You can use another webhook to test it out, like, okay, assume that this webhook is going to the website. I am sending the data from the pipeline already transformed to the webhook. Input also webhook, output also webhook. Clear? Now, I'm creating pipeline. Now, compared to the other kind of solution without infrastructure, as you can see, I'm not writing code. I am just implementing easily with the low code. And the next step, I'm going to create now webhook for the database change. Let's say I'm going to create new webhook and call it like a trigger. Something happens in the database for each insert or for each update or for each delete. And then it will send the event to the webhook, and webhook processes as inside the data pipeline. Now, here we go, car price change detector, and I'm specifying my table in Superbase, and it triggers in every insert event. Whenever a new car price is added, it will run the pipeline. And then I'm specifying output is my data pipeline. So some access token, of course, you would like to connect to your data pipeline securely. So here we go, create the pipeline. The magic part is going to happen now. whenever I tried like to insert some data and some dummy data again using the SQL editor, and you will see the output immediately will be visible on the webhook side. Let's say I'm inserting 4 new data, let's say new car information, some automatic, electric car, and so on. And whenever I edit this data, if you navigate to the paper pipeline, if you see the logs, you will see the data is coming quickly to the pipeline, and it's processing with AI and predicting the car price. Here we go. Here is data is coming. Which there was some errors happening. Probably I missed it to import some library additional like OpenAI. And here we go. Because the transformation now is running in a serverless environment, you need to specify which library you would like to use inside the transformation. So now everything should be fine. Then you will see on the webhook side now, message is sent. And a couple of seconds, and we will go to the webhook. Let's go. Yes, here you go. As you can see, the output data is coming with suggested price immediately. Within the minutes, like we were able to build a pipeline with easy steps with both solutions. Like we understood the challenges, right, with the infrastructure without even implementation. Now this solution is already prod ready. I mean, it's running in the prod. And you don't have to monitor anything. There are monitoring systems available. So that was something I want to show you about real-time data pipelines. It's more like a future for us, because everything now AI is improving, and it requires a lot of real-time data in the upcoming days. Now we are training AI mostly, with all data, right? All data we're giving, it's training and it's giving some output to us. And these pipelines can help us to train the AI with more streaming data. Because AI can know where I am now, to whom I'm speaking, and at this moment AI can analyze this. So that was kind of my small presentation about data pipelines. Here's a summary. What I want to say, as you can see, data engineers nowadays facing some problems. Problems was a challenge with infrastructure, because the challenge is they don't know Java. They want everything in Python because of libraries. There are a lot of limitations. And Bob, what he did, he chose Python frameworks to work with future mRNA pipelines. Obviously, he was able to build his solution, second solution, in 15 minutes. That was kind of my presentation, all this about. So now we can switch to some Q&A session. I will try to my best to address your questions. I see, because after non-technical, always technical topic is quite boring, I know. That's why I had to suggest, maybe next time we'll try to also bring non-technical. I have 2 topics. I would like to do, maybe Kirill or DEVCLUB can support me. Interesting topics I have, what developer relations they do. I'm gonna, if it's interesting for you, I'm gonna explain how I started myself, this business, and what I'm doing, how I'm helping to companies. And next topic I have interesting title, I will never do and take a interview home task. Why I'm going to explain this, why I'm not taking it. I start to write an article, a very good article. When I finish, I will convert this to the speech. It will be exciting, hopefully. But now, is there anyone questions any? I would love to hear from Kafka users. They hate me now, right? Over, shut down, go out. Yes, go ahead.
Why do you need a vector database for the car price demo? Because it's good structured data, and what field do you use for vector?
Yeah, thank you. I think maybe I confused the diagram here. In this diagram, you don't need, of course, vector database. You need vector database when you would like to search or do some recommendation systems with human language, let's say. In this case, everything data is structured. It's not unstructured. That's why we don't need vector database, obviously. That's why here I used Superbase. Superbase is not a vector database, but just a SQL style database, a relational database. But I can talk more maybe later also in which case you can use vector database. Probably you know better also if you implement it, right? Go ahead. Yeah.
Maybe you can explain to people who don't know what is vector.
Okay.
In
Yeah.
that,
Yeah. My friend knows. I can explain. Vectors. When we say vectors, let's say you have two texts. One is good and one is bad. Two words like good and bad, right? And if you convert to vector representation, it will become good becomes x and y, right? 2.1, and then bad becomes 1.2. As a vector representation, you work choose two numbers, x and y, of any your data. Data can be image, video. You can convert video and images, text into vector representation with these coordinates. This is a vector. And where we can store these vectors? Can I store in PostgreSQL? Yes, I can store in relational database, of course. Storing is quite fast, but querying is quite slow, because querying takes a lot of time when you have working with big data. Like assume that good and bad I stored, but now the user asks, okay, show me all 1,000 good people around me, and then 1,000 bad people around me. And for this query, PostgreSQL thinks a long time, because it should find the users, 1,000 users, and match which users are bad or good. But if you have representation of the vector, vector representation compares vectors, not a text, not let's say some SQL queries. That's why we store in vector database. But nowadays, AI applications using the vector database, but graph database are becoming, as they are winning. I assume that vector database will be replaced also soon with graph database, because now AI is also working fine with graph database.
You did mention that vector can be really big, multi-dimensional.
Yes. Multi-dimension in case like we have, like especially videos, images.
It can be a very big number.
Yeah, very big number, long number, depending on the how the image's quality is low or high, resolution, so on, and size. Hopefully this explains. And everybody now knows vector database, or I can explain more better vector database. Okay. Other questions?
What prompt did you send to the OpenAI?
What kind of prompt?
Yeah.
Okay, the prompt I showed is very simple. This is the input of the car data. The car has a fuel type, car has a engine type, and which year is like built, developed. And I'm saying, hey, you're a data analyst, very good, expert. Analyze this input data to predict future price, suggest the price for the car. This is only a simple prompt I did. In reality, it doesn't work in real projects. Sometimes you need to implement your own ML, machine learning project. Difference between AI and machine learning, LLM providers, they train for you some data, but you need to train your AI. In this case, you need to build ML solution, because AI should be customized for you. Yeah, thank you for the question.
Okay, thank you for your
Yeah, thank you.
presentation.
I have actually this.